So here is a really interesting question to kick things off. Is AI automatically sustainable just because it makes us more productive? We often assume that because an AI tool saves us a bunch of time, like, say, generating a massive report in seconds instead of hours, it absolutely must be a win for the environment too. But does a faster process naturally equal a greener one? Welcome to the Explainer. Today, we are looking at Green AI Part 2, From Unlimited to Intentional AI. We're going to explore a massive paradigm shift. We have to stop treating computing power like this invisible, infinite resource floating up in the cloud and start managing it deliberately. It's all about making conscious choices that maximize public value without ignoring the very real physical footprint of our digital tools. Okay, let's dive into this. Our roadmap today covers 6 quick areas: the Green AI Contradiction, minimum sufficient intelligence, the rebound effect, 4 tests for responsible AI, the agentic AI challenge, and finally, choosing intentional AI. Starting right off with Section 1, the Green AI Contradiction.
Now, don't get me wrong, AI offers massive, undeniable benefits for public services. Think about NHS scheduling, preventative maintenance, or slashing those heavy administrative burdens. But the contradiction really lies in how we make our comparisons. We have this habit of measuring AI versus doing nothing, and honestly, that is a deeply flawed metric. Just claiming that AI improves productivity doesn't automatically justify its environmental impact. Instead, we really need to compare AI versus all credible ways to achieve the intended outcome. An inefficient process doesn't just magically become sustainable because an AI made it faster. I mean, could you simply redesign the process? Would a basic search function or rules-based automation actually do the trick? Sometimes, believe it or not, the most responsible and innovative choice is just to remove the unnecessary work entirely. Let's look at Section 2, Minimum Sufficient Intelligence.
This brings us to what I think is the core guiding philosophy for anyone looking to deploy AI intentionally. So, what exactly is minimum sufficient intelligence? Simply put, it's using the least resource-intensive capability that can complete your tasks safely, reliably, and to the required standard. Look, the AI market understandably wants to sell us massive, frontier, multimodal models for absolutely everything. But a routine data classification task? It probably doesn't need a giant generative model. A frequently asked question is often way better served by a simple, curated database. And the best part? This principle isn't just about saving carbon, it actually supports your bottom line. It improves affordability, operational resilience, faster response times, and gives you much better data control. Let's move to and see how this builds into a highly practical AI choice hierarchy. It starts right at the top with the simplest, most effective option: remove or improve the process entirely. If you can't do that, step 2 is applying rules-based automation. Step 3 is stepping up to small or highly specialized models. And only at step 4, at the very bottom of this funnel, do we deploy those large agentic systems that make complex decisions. This definitely doesn't mean you can never use a powerful model. It just means the choice has to be conscious, not automatic. And when we talk about making those conscious choices, where the processing actually happens is a massive factor. This quote really hits the nail on the head. Architecture should therefore be assessed as a whole system. Slogans such as "cloud is greener" or "edge is efficient" are not enough. We literally cannot rely on catchy but incomplete marketing anymore. Microsoft's 2026 Environmental Sustainability Report, for instance, heavily links AI growth directly to the massive physical realities of data centers, energy systems, and global supply chains. So whether you use hyperscale cloud or local on-device processing, you have to look at the workload, the energy source, and the hardware lifecycle as one complete, interconnected system. Moving on to Section 3, the rebound effect. This is perhaps the most hidden and honestly most dangerous pitfall of AI efficiency. Here is the trap. When marginal effort appears close to zero, total usage rises. AI fundamentally removes friction. Today, you can generate a summary, a complex image, or a whole presentation in mere seconds. But because it is just so incredibly easy, it creates demand that never existed before. Someone might casually generate 10 different versions of an image instead of just thinking carefully about one. A system might be set up to automatically summarize every single meeting, even if literally no one ever reads the output. The efficiency improves per transaction, for sure, but the total energy consumption skyrockets because the sheer volume of transactions explodes. So the crucial point is that organizations absolutely must distinguish between types of compute. On one side, we have useful compute. This supports worthwhile, proportionate outcomes. It's the stuff that actually releases staff capacity or improves a patient's experience. But on the other side, we have avoidable compute. This is the bad stuff. It stems from poor design, duplication, unnecessary generation, or just lazily picking a massive model when a small one would do. Just like organizations actively challenge unnecessary business travel or excessive printing, we have to start aggressively challenging avoidable compute. So how do we actually do that in practice?
That takes us to Section 4, 4 tests for responsible AI.
This table outlines a brilliant, highly actionable framework. The 4 tests are purpose, proportionality, efficiency, and value. First up, purpose. Is there a genuinely worthwhile problem being solved here? Second, proportionality. Is AI actually the appropriate tool, or could a simple template work just fine? Third, efficiency. Are we using the right-sized capability, or is data being processed repeatedly for no good reason? And finally, value. Does the benefit justify the resource consumed? Notice that we aren't just reducing every decision to carbon emissions alone. We are actively weighing the environmental cost alongside the financial, clinical, and operational value. But here's the thing, applying these tests isn't just on the end user. We need shared accountability. You can't just make every single employee feel terribly guilty every time they type a prompt. The heavy lifting really sits elsewhere. Suppliers need to step up and provide transparent energy and hardware data. Procurement teams must ensure sustainability is a strict, measurable, contractual requirement. Product owners have to carefully decide what defaults are activated to prevent automatic unseen generation. And boards absolutely must integrate AI demand deeply into their overarching technology and sustainability planning. Section 5, the Agentic AI Challenge. This accountability we just talked about, it is becoming even more critical right now. We are moving incredibly fast from AI that just responds to our prompts to AI that takes action on our behalf. Agents will soon search, summarize, reason, and trigger workflows entirely on their own. The 2026 Stanford AI Index report heavily emphasizes the blistering pace of this AI adoption, the capability growth, and the increasing attention on its environmental footprint. The sheer speed of this shift makes robust governance more urgent, not less. Because think about it, if an autonomous agent is poorly designed, it can create a persistent, totally opaque, and infinite loop of low-value demand that just silently drains resources behind the scenes. And this brilliantly illustrates why the solution to this risk comes down to essential agent guardrails. To prevent those nightmare infinite loops, agents absolutely require clear goals, strictly limited permissions, and crucially, built-in stopping conditions. An agent that nobody owns, nobody observes, and nobody retires isn't just an environmental disaster waiting to happen, it's a massive operational and financial risk. We desperately need strict cost monitoring and highly accountable ownership for every single autonomous system deployed. Finally, Section 6. Choosing intentional AI. Before we wrap up, it's vital to remember one huge caveat. Sustainability must not become a barrier to inclusion and accessibility. Environmental concerns should never, ever be used to restrict AI applications that reduce cognitive burdens or enable people to participate more fully at work. A capability that removes a significant barrier for even one person can be incredibly valuable regardless of the compute volume. Responsible consumption is about weighing resource use against genuine human benefit, not just issuing blanket rations across the board. Ultimately, the choice we face is a massive shift in mindset. We absolutely must move away from unlimited AI, where adoption is careless, computing power is treated as an invisible, infinite resource, and lazy default settings drain power for literally no reason. Instead, we have to embrace intentional AI. This means deliberate adoption. It means preventing unnecessary computation at the very design stage and making sure we extract the maximum worthwhile value from the resources we do choose to consume. I'll leave you with this powerful final question right from our source material. Should organizations account for AI compute in the same way they account for money, workforce capacity, and carbon? And if not, why not? Good intentions just do not remove physical consequences. It's time we stop treating compute as invisible. Thank you for joining me for this explainer, and I really hope this helps you approach your digital tools with a new, deeply intentional perspective.